So in last video we discussed about the role of complexing agent in the separation of lanthanide ions by ion exchange method. Now in this video we are going to discuss the separation of lanthanide ions by solvent extraction method. And the solvent extraction method, it is one of the recent and very efficient method for the separation of lanthanides, which is based upon the distribution of substance between two immiscible liquids or two immiscible solvents. And generally when aqueous solution of substance is brought in contact with another solvent, mostly organic, which is immiscible in water, then the substance, it is distributed between two solvents, aqueous phase and organic phase. Okay, and when it is enter into the organic phase is separated by means of separating funnel itself, and when organic solvent is evaporated, we get component, or the two components gets separated. This is very simple technique, and this solvent extraction method, it is based on Nernst partition law. And according to Nernst partition law, the ratio of concentration of solute into two immiscible solvents, it is a constant at a constant temperature. And you know that generally ionic compound, it is soluble in polar solvents like water or solvent having more dielectric constant, whereas organic compounds, these are soluble in non-polar solvents or organic solvents. Now when organic solvent containing chelating agent, it is shaken with aqueous solution containing lanthanide salts, then the lanthanide ions form uncharged or less polar complexes with chelating agent, and which enter into the organic phase, and therefore they are extracted by using suitable organic solvent. For example, when lanthanum salt containing lanthanide ions, these are mixed with chelating agent, suitable chelating agent, they form the chelate. And first of all, this chelate exists in aqueous phase, that is LnR3, and as polarity of this chelate is less than the lanthanum salts, this chelate or complex of lanthanum ion, it is more soluble in organic phase, and therefore as soon as chelate is formed, it enter into the organic phase or organic solvent, and therefore the ion, lanthanum ion, gets automatically separated. So here in short, the lanthanum salt, it is first of all mixed with chelating agent, and sufficient quantity of organic solvent is added. So as soon as chelate is formed, that chelate, it is soluble in organic phase, and therefore automatically it is separated from the aqueous phase. Now extraction with N-tributyl phosphate, that is TBP, N-tributyl phosphate, it is one of the good solvent, organic solvent used for the separation of lanthanides. So tributyl phosphate, it is selected as a solvent because it is very efficient in nitric acid medium. It has a higher distribution coefficient value. It can be diluted with kerosene in order to decrease the cost. It is diluted with kerosene without lowering efficiency. And when lanthanide salt, especially nitrate, it is shaken with tributyl phosphate in kerosene, then lanthanide ions form less polar complexes, which are extracted in organic phase. So here lanthanum nitrate, Ln3 plus 3NO3 minus. So lanthanum nitrate, it is a salt, and in aqueous phase lanthanum nitrate, it is dissociated. So to this aqueous phase, when tributyl phosphate is added, this is organic solvent, tributyl phosphate is added. So this tributyl phosphate forms the complex, and this complex, it is insoluble in aqueous phase, and automatically we get two layers. So organic layer is separated, and then this solvent is removed, and we get lanthanide ions separated from one another. Actually, this method, solvent extraction method, normally efficient for the separation of +3 oxidation state lanthanide ions from other oxidation state lanthanide ions like +2, +4, etc. Even it is useful for separation of lanthanide ions with +3 oxidation state from thorium +4. Now the distribution of lanthanide ion between aqueous and organic phase depends upon the value of distribution coefficient, that is lambda, and distribution coefficient lambda, it is equal to concentration of the lanthanide ion in organic phase upon concentration of lanthanide ion in aqueous phase. So for one lanthanide ion Ln3 plus, distribution coefficient, it is equal to concentration of lanthanum salt, actually concentration of lanthanum salt in the form of complex with tributyl phosphate. So this is the concentration of lanthanide ion in organic phase upon concentration of lanthanide ion in aqueous phase. Similarly, for other lanthanide ion, for example Ln3 plus dash, we can write lambda dash, that is distribution coefficient for other lanthanide ion, it is equal to concentration of that lanthanide ion in aqueous phase in the form of complex upon the concentration of Ln dash 3 plus in aqueous phase. Here it should be dash. And separation factor alpha, it is the ratio of distribution coefficients of two different lanthanide ions, that is lambda dash upon lambda. So we know lambda dash and lambda, just we take ratio. So alpha is equal to concentration of Ln or lanthanum, one lanthanide ion in organic phase in the form of complex into concentration of Ln aqueous upon concentration of other lanthanide ion in the form of organic phase or in the form of complex into concentration of Ln dash in aqueous phase. So this is what is alpha, and based on the concentrations or ability to extract a particular ion in organic phase, based on this fact alpha will deviate from unity, and the average separation factor for 15.8 molar nitric acid with 100% tributyl phosphate solvent, it is 1.5. It means alpha substantially deviates from unity, and therefore solvent extraction method, it is effective. Now again you consider the equilibrium, that is when lanthanum salt, it is mixed with tributyl phosphate organic solvent, then this organic solvent extract, or first of all it forms the complex with this lanthanum +3 ion, and automatically the lanthanum +3 ion enter into the organic phase. So this is the organic phase, and this is the aqueous phase, and this is the solvent. So applying law of mass action, the stability constant, it is given by concentration of lanthanide ion in organic phase upon concentration of lanthanum ion in aqueous phase into concentration of the solvent. So K is equal to concentration of Ln NO3 tributyl phosphate thrice, so this term, upon concentration of Ln3 plus aqueous, this one, into concentration of NO3 minus raised to 3, because here coefficient is 3, into concentration of tributyl phosphate organic raised to 3, again here coefficient is 3. So this is the stability constant. Now but we know that distribution coefficient lambda, it is the concentration of lanthanide ion in organic phase upon concentration of that lanthanide ion in aqueous phase, and therefore K is equal to, actually just we substitute the value of this. So lambda is equal to C ln NO3 tributyl phosphate thrice upon C ln 3 plus aqueous. So in this stability constant term, there is a C ln NO3 thrice tributyl phosphate thrice organic upon concentration of Ln3 plus aqueous. So instead of this we are writing lambda. So K is equal to lambda upon concentration of NO3 minus raised to 3 into concentration of TBP organic raised to 3, and just by rearranging terms, lambda is equal to, that is distribution coefficient, it is equal to K into C NO3 minus aqueous raised to 3 into concentration of tributyl phosphate organic 3. Okay, so now next part is when log distribution coefficient, it is plotted versus concentration of nitrate ion at a fixed concentration of solvent, that is tributyl phosphate, a straight line is obtained like this. So along the x-axis, concentration of nitric acid is taken, 5 molar, 10 molar, 15 molar, like that, and along this y-axis log lambda values are taken. So we get a straight line, and here important thing is, from this graph it is clear that basically the extent of separation increases with increase in concentration of nitric acid. This is one thing. It also increases with decrease in radius. Now consider these lanthanides: neodymium, gadolinium, dysprosium, erbium, ytterbium. So because of lanthanide contraction, ytterbium ion has, or it is the smallest ion, it has a lower ionic radius or smaller ionic radius, and its separation, it is easier. So extent of separation increases with decrease in ionic radius. This is very important thing. And now summary of this point: by solvent extraction method, it is possible to separate lanthanide ions from one another. It is based on the Nernst partition law, and according to Nernst partition law, the ratio of concentrations of solute in two immiscible solvent, it is a constant at constant temperature, and tributyl phosphate, N-tributyl phosphate, it is one of the effective solvent for the extraction of lanthanides, from the mixture.